Uh, Welcome to session 2, air pollution and public health. And we have here six speakers. And first speaker is Professor Neng-Huei Lin, or we call it George Lin. He's uh, uh, renowned in this aerosol science, and he was basically PI for 7C experiment. Lot of work has been done on 7C.
फोटो तुम इधर से ले लेना
Yeah, so
इसके बाद
I think now you can start, George. Now people are there.
Okay, may I start?
Yeah, please.
Okay, thanks, Umesh. It's my great pleasure today to introduce our recent activities. Particularly, we have the long-term project called the 7Cs project since 2007 until now. And in cooperation with NASA, Asia and AQ, I will introduce later. So I will give you very quickly a brief overview about these two projects and very preliminary results. Okay, and so today I will not go into the very detailed science results. So there's so many people involved in these two projects. Okay, the 7-6 project, they call the 7 Southeast Asian Studies. This since 2007. NASA and US Navy, they initiate this project and invite the Southeast Asia countries such as Thailand, Vietnam, Malaysia, Singapore, Indonesia, the Philippines, and Taiwan. Try to study the biomass burning issue in Southeast Asia regions. So as far as you know, the biomass burning is the important the pollution in Southeast Asia in springtime for the northern region and the summertime to autumn for the south part of Southeast Asia. So what's the major topics the 7Cs try to study? There's 7 topics about the aerosol, life cycle, air quality, tropical mineralogy, radiation and heat budgets, cloud and rainfall, land process, and the oceanography, and mostly it's very important for vegetation analysis and the prediction for the satellite and air quality model. And since 2007, the initiate of the 7Cs, we have the workshop and the training every year, and we have the in situ experiments, particularly in northern part of Southeast Asia since 2010, and we have conducted several campaigns. For example, phase 1 for Dongsha experiment, Sunlight campaign, and the phase 2 for baseline, and phase 3 for data analysis integration, and Bang Doi Enkang experiment. And phase 4, because of the pandemic, so we just stopped our campaign. But here last year, we cooperation with the NASA Asia and AQ flight mission together, and Taiwan under the 7Cs, we proposed the KPEx to try to study our southern Taiwan air pollution issue. So the previous 7Cs campaign, now you can see on the panel for the northern part of Southeast Asia. So during the springtime, we set up the several sites for the to observe the aerosol, biomass aerosol chemistry and physics, try to categorize their features over the source region, for example, northern Thailand, northern Vietnam, all the way down to the receptor region, Taiwan. And not only for the aerosol physics and the chemistry, but also the aerosol cloud interaction. So from this panel, you can see this two color by the MODIS. The red color means the biomass burning aerosol. The white one is for the cloud. So clearly, you can see the clear cut between the before and after, you can see the interaction between the aerosol and the clouds over the northern Vietnam region. And we construct the conceptual model for the regional circulation. So you can see the uplifting burning balloon over the south region, and the balloon, the participant balloon, just travel along with the westerly flow all the way down to the receptor region, Taiwan. And if we closely to look at the interaction between regional circulation and the local circulation, so you can see the westerly flow under certain condition. Actually, this high-level transport balloon can, through the downwash effect, to the central and the southern Taiwan. And we have some idea about the KPEx. The KPEx means we try to study the air pollution issue in southern Taiwan, where is the most populated and also the pollution area in Taiwan. So we have the pilot study for the KPEx 2 years ago. We have the UAV launched with the PM 2.5 around the southern Taiwan area. So and we have a 3 days experiment. Probably previous speaker Carlo Wang has already mentioned about this. This is the kind of 3 days experiment, hourly UAV and the PM 2.5 observation by the UAV. So now we can see the highlights of the PM 2.5 over the higher level above the 800 meter. So obviously this two-layer structure, you can see during the nighttime, due to the inversion layer effect, now you can see the accumulation of the PM 2.5 near the ground. However, during the daytime, you can see another layer of the PM 2.5. And we composite the previous years the airflow along with the high PM 2.5 event. Then we can see two kind of airflow condition and associated with the high PM 2.5 pollution. And you can see the pattern one, the prevailing northeast wind. So you can see the produce the vortex over the southern Taiwan. However, the pattern two, when the wind turns to the east, then you can see the two vortex forms from the southern Taiwan to central Taiwan. So you can see the shifting of the prevailing wind from northeast wind to east wind. Then you can see the movement of the vortex from the south to the central Taiwan. And how about ozone? Then you can see the ozone hotspot here on the west coast of Taiwan Island. However, near the surface, 780 meter, 1,500 meter, then you can see the different flow pattern. Near the surface, you can see the northeast wind, and also literally change it to east wind over the southern Taiwan, and higher up, then you can see the east wind. However, to the 850 millibar, you can see the wind turn to the south wind. So you can see the very different condition for the regional and the local circulation associated with the high ozone event. So now give you some idea. We make the 2 minutes video and try to explain the reason why we want to conduct the KPEx.
Southern Taiwan frequently suffers from poor air quality in winter and spring. To understand the causes, the 3D Gaoping experiment, or KPEx, was launched. Taiwan's geography exposes it to transboundary pollution via the northeast monsoon, accumulating air pollutants in southern Taiwan. Valley wind circulation and the convergence of westerly sea and land breezes further worsen this air pollution. Biomass burning in Southeast Asia also impacts Taiwan through prevailing westerlies. Under certain conditions, these westerlies cause unique air pollution events. Thus, air pollution in Taiwan is not only caused by local emissions, but also by variations in regional airflow patterns. Conventional ground-based measurements lack vertical profiling and fail to fully capture these airflow dynamics. Satellites and AI can provide vertical aerosol data to clarify these details. This year, Taiwan collaborated with NASA for the first time on an aircraft-led project. The DC-8 and G-3 aircraft monitored various air pollutants, strengthening the KPEx campaign. KPEx focused on pollutants like PFAS, PAHs, dioxins, and microplastics, which concern the public. A total of 15 interdepartmental ministries, 20 academic and research institutions, and 45 professors and scholars participated in the experiment. Together, we can safeguard our blue skies.
So, what's specific concern and the issue we are going to understand through the 7 KPEx? The KPEx is regarding as the downwind experiment under the 7 project. So, number one, process of ozone and the secondary organic aerosol formation, and the cause of visibility in Gaoping area, role of local and the regional circulations and the terrain effects on the local air quality, and resolving the vertical profiles of pollutants and the atmospheric structure and the effect on local air quality, and how well can the air quality model perform in Gaoping area. How can remote sensing enhance the monitoring capacity on air quality? Finally, of course, we have to do the source identification and provide the Taiwan Ministry of Environment for the air pollution control strategy. And about the NASA Asian AQ project, this is a flight mission, including Korea, Malaysia, the Philippines, and Thailand. And during the transit between the 3 bases in Seoul, Manila, and Bangkok, NASA provided 4 times overflight to Taiwan and try to understand the local air pollution issue. So for the DC-8 and the G-3, DC-8 is kind of the 4-engine big airplane carry 26 the high quality instrument to measure the continuous the air quality. So basically that's for the like ozone aerosol and the air precursor. And the G3 is a high level air purifier. They try to they have the airborne lidar and the spectrometer to detect the vertical and the horizontal distribution of the ozone and the aerosol and the formaldehyde. And this is the flight trick for the DC-8 and the G3. So look at the DC-8. If from Manila, you can see the fly and go along the west side of the southern Taiwan to central Taiwan and come back, and for 4 times, and leaving from the east coast. And if the DC-8 take off from Seoul, then we come fly along the east side of Taiwan and come to the southern Taiwan to central Taiwan and come back and forth 4 times and leaving to the Philippines. And then for GC3, for the G3, this kind of a scanning mission. So along the west side and then come back and forth 7 times. And in line with the Asian AQ, the KPEx, we conduct the 4 IOP intensive observation period on February 15 and 28, March 13 and 27. And how about our IOP design? On the day of the Asian AQ flight, overflight over Taiwan, we conduct 1 day before and 1 day after, totally at least 48 hours observation on the ground and vertically. And on this right panel, you can see the red one. This is the flight area for the DC8 and the DC8 and the G3. And the blue one is the area studied by the KPEx. So this picture shows you the concept, the core concept about the satellites and the fly mission and the UAV, and also the LiDAR and the sounding for the three-dimensional structure for the meteorology, and the PM 2.5 and the ozone and their precursor, and of course including the air quality modeling. So, and for the KPEx, the major task for the observation will be flow and the vertical profiling of the pollutants and atmospheric structure, and for the air quality measurement on the surface with ozone aerosol, the POP hubs chemistry, visibility for the aerosol physical optical properties, source apportionment, model validation and improvement with the observation, and finally for the remote sensing validation and application. So just show you some design. The left preview shows you for the vertical profiling. So you can see the sounding around the island and the mini sounding in over the southern region, and also some other LiDAR, for example, the micropulse LiDAR and the wind LiDAR, wind profiler, and the aeronet. And the right-hand side is for the aerosol, for the chemistry. So you can see two super sites, one from NASA, one from Taiwan, and another 5 stations for the aerosol chemistry, and also 3 stations for the UAV launching from Linyuan and the Wanwan and here Yanchao. This is for the vertical profiling for the aerosol and the ozone and their precursor. So just show you some example. This is the 4 IOP, the airflow structure from the surface up to the 700 millibar. So you can see this is combined with the model and the observation. So you can see for this 4 IOP, basically the IOP3 is the long-range transport event, and the IOP1 is relatively clean, and the IOP2 and IOP4 is enhance the local pollution. So these 4 events, we are very lucky. We have a long-range transport impact from outside, and very light and heavy local pollution events. And this is one of the events.
1 minute, please.
Oh, sorry, I will go quickly. So you can see the model simulation and the Himawari, the image. So you can see the cloud band just associated with the conversion of the airflow. And then this is the vertical observation by the DC8 over the 3 events. So you can see for the ozone and their precursor NO2 and benzene taurine. So you can see this kind of data we have. And then finally, we do some comparison between our model UAV and DC8, the observation. So we can find out for the ozone, the observation and the model is pretty much comparable. However, for the PM 2.5, in higher level is totally wrong. So which means the model should be significantly improved based on this observation. So in the future, we will calibrate the model. Finally, this figure just shows the whole work. Now we have the observation over the ground and the vertical profiling, and also NASA's data. And we can use this to calibrate our model and the satellite. Finally, we want to do in the future, we want to can use those data to provide the better service for the air quality forecast and also the satellite application. Okay, thank you so much. Yeah.
Thank you very much, George, for timely completing and giving overview of 7 Seas and Asia IQ. Thank you very much.